What if the greatest assumption we've ever made about our planet is also the most fragile one? We look at the world around us, cities glowing at night, satellites crossing the sky, machines reshaping landscapes, and we assume something without ever saying it out loud. We assume that this is the first time Earth has looked like this. That intelligence capable of altering the planet has only happened once. That out of 4.5 billion years of planetary history, we are the only ones who reached this point. But assumptions are not evidence, and Earth has had a very long time to forget. Before we go any further, take a moment. If you find yourself drawn to questions like this, questions that sit at the edge of science and deep time, consider subscribing. These explorations only exist because there are people willing to slow down and think carefully. And if this story keeps you listening, a simple like helps it reach others who might be wondering the same things in the quiet hours of the night. Now let's begin properly. Imagine standing on a shoreline just after sunset. The sea is black and restless, reflecting nothing but faint starlight. You scoop a handful of sand and let it slip through your fingers. Each grain represents a year. The sand in your palm, just that small amount, contains every year of recorded human history. Writing, cities, empires, science, industry, everything we remember. Behind you, stretching into darkness, is the rest of the beach. That beach represents 4.5 billion years. Somewhere out there, beyond memory, beyond written record, beyond even fossils that we know how to interpret, lies a question that modern science only recently dared to ask. What if we are not the first? In 2018, 2 respected scientists did something unusual, not reckless, not sensational, just uncomfortable. Astrophysicist Adam Frank from the University of Rochester and climate scientist Gavin Schmidt from NASA's Goddard Institute published a paper in the International Journal of Astrobiology that posed a deceptively simple thought experiment. If an industrial civilization had existed on Earth millions of years before our own, would we be able to tell? They weren't suggesting that dinosaurs built cities or that ancient reptilian beings ruled the planet. In fact, they explicitly stated that they doubted such a civilization ever existed. Their goal was far more subtle and far more unsettling. They wanted to understand the limits of detection. We often say, there's no evidence anyone came before us. But what if the problem isn't absence? What if the problem is erasure? Earth is not a museum. It is not an archive. It is an active system that grinds, melts, folds, buries, dissolves and recycles everything on its surface. Mountains rise and disappear. Oceans open and close. Entire seafloors vanish into the mantle every couple 100 million years. Even continents themselves are temporary features on geological time scales. Complex life has existed on Earth for over 500 million years. Dinosaurs ruled for more than 150 million of those years. Our own species, Homo sapiens, has existed for roughly 300,000 years. And the industrial civilization that defines us? About 300 years old. 3 centuries. If Earth's history were compressed into a single calendar year, everything from the first factory to the present moment would occur in the final second before midnight on December 31st. Now ask the uncomfortable question. If a civilization rose and fell during any of the other 364 days, how would we know? The fossil record gives us the illusion of completeness, but it is anything but complete. Fossilization is rare. For an organism to fossilize, it must die under specific conditions, be buried rapidly, avoid scavengers, undergo mineral replacement, survive tectonic stress, avoid erosion, and then somehow be exposed at the surface, where someone notices it. Scientists estimate we have fossil evidence for less than 1% of all species that ever lived. Civilizations are even harder to preserve than organisms. Cities are localized, technology corrodes, materials degrade, concrete cracks, steel rusts, plastics fragment, and after enough time, even stone loses its shape. Give Earth 1 million years and almost nothing recognisable remains on the surface. Give it 10 million and even buried structures are folded, crushed or transformed into something unrecognisable. Give it 100 million and the surface itself may no longer exist. This is the foundation of what Frank and Schmidt called the Silurian Hypothesis, named not as a claim but as a placeholder, a way to ask, are we mistaking absence of evidence for certainty? To explore that, they flipped the question around. Instead of asking whether anyone existed before us, they asked, what will remain of us? Not in 1,000 years, not in 10,000, in 10 million. The answer is not comforting. Our buildings will vanish. Our cities will erode. Our monuments will collapse. Even Mount Rushmore will eventually become dust. But some traces will remain, subtle ones, chemical ones, carbon isotopes altered by fossil fuel combustion, a sharp spike in greenhouse gases, a sudden mass extinction visible in the fossil record, synthetic compounds embedded in sediment, radioactive isotopes from nuclear testing spread across the globe. These are not monuments, they are scars, and here is where the thought experiment becomes disturbing. Earth's history already contains events that look very similar. There are periods where carbon flooded the atmosphere rapidly, where global temperatures spiked, where oceans acidified, where ecosystems collapsed. One of the most famous occurred about 56 million years ago, the Paleocene-Eocene thermal maximum, a massive carbon release, a rapid warming event, extinctions, recovery. Scientists believe it was natural, volcanism, methane release, orbital cycles, and they are almost certainly correct. But Frank and Schmidt asked something else. If a technological civilization had caused such an event, would we be able to tell the difference? Would we recognise it as artificial? Or would we label it natural? Because that is what we expect to find. This is not a claim that such civilizations existed. It is a warning about confirmation bias. We find what we look for, and we do not look for what we assume cannot exist. There are strong arguments against prior civilizations. Fossil fuel deposits were still available when we industrialized. Resource extraction patterns don't show prior exploitation. There are no ancient satellites on the moon, no ruins on Mars, no unmistakable technofossils buried in ancient rock. These arguments matter. They are serious. They are why most scientists believe we are alone in Earth's history. But belief is not certainty. And the Silurian hypothesis does something important. It exposes how thin the line is between confidence and assumption. It reminds us that deep time erases almost everything. It reminds us that intelligence does not guarantee permanence. And it forces us to confront a far more personal question. If Earth forgets so easily, what will we become? Not remembered heroes, not founders, not pioneers, just another thin layer in stone. And if that is true, if Earth has forgotten before and will forget again, then the real question is not whether someone came before us. It is whether we are paying attention to how quickly we could disappear. The most dangerous misunderstanding about Earth is that it keeps records. We imagine layers of rock like pages in a book, one neatly stacked on top of another, a timeline waiting to be read. But this image is comforting and wrong. Earth does not archive, Earth recycles. To understand why the deep past is so silent, we must understand the machinery that destroys it. Begin with erosion. It is slow, relentless, unimpressive and unstoppable. Rain falls, rivers form. Wind scours exposed the stone. Glaciers grind mountains into powder. These processes operate continuously, without intention, without pause. Over thousands of years they smooth landscapes. Over millions, they erase them. The Appalachian Mountains once rivaled the Himalayas in height. Today they are rounded, subdued, worn down to their roots, not by catastrophe, but by time. Now imagine a city built into that landscape. Stone walls, towers, roads, bridges. To us, these structures feel permanent. To geology, they are fragile interruptions. Within decades, vegetation would reclaim them. Roots pry apart stone. Water seeps into cracks. Freeze-thaw cycles fracture foundations. Within centuries, roofs collapse, walls fall. Within a few thousand years, nothing remains but scattered rubble, indistinguishable from natural rockfall. And this is only the surface. The deeper eraser lies beneath our feet. Earth's crust is not static. It floats on a slow-moving mantle like ice on a viscous sea. Continental plates drift centimetres per year, about the speed your fingernails grow. Over millions of years, those centimetres become continents. Where plates collide, one slides beneath the other. This is subduction. Entire regions of Earth's surface are pulled downward, heated, compressed and melted. Everything on them, sediment, fossils, structures, history, vanishes into the mantle. No artefact survives subduction. No city escapes it. No civilization leaves a trace. The ocean floor is especially vulnerable. Unlike continents, which can persist for billions of years, oceanic crust is young. Almost none of it is older than 200 million years. It is constantly being created at mid-ocean ridges and destroyed at subduction zones. Anything that happens on the ocean floor, settlements, artefacts, ecosystems, is erased on a geological schedule. This matters more than it seems. For most of Earth's history, coastlines were different. Sea levels rose and fell dramatically. Vast regions now submerged were once dry land. Entire human populations once lived on continental shelves that are now underwater, and anything older than a few 100 million years that occurred near the ocean is gone, not buried, not hidden, gone. Then there is metamorphism. When rock is buried deeply enough, heat and pressure change its structure, minerals recrystallize, layers fold, fossils stretch, smear or dissolve. Sedimentary rock becomes schist, limestone becomes marble, sandstone becomes quartzite. The original story is rewritten. Even if an artifact were buried safely, time would deform it until it no longer resembled anything artificial. Edges blur, shapes compress, materials transform. After enough time, you are no longer looking at history, you are looking at chemistry. This is why the oldest rocks on Earth are so difficult to interpret. We extract meaning from zircon crystals, tiny minerals that preserve atomic clocks, not shapes, not structures, just isotopes. This is the limit of memory. Now consider the fossil record. It feels rich because museums are full. Dinosaurs loom, skeletons tower. But this is an illusion of abundance. Fossils are rare beyond imagination. Most organisms that have ever lived left no trace, no bone, no imprint, no chemical shadow we can recognise. They died in the wrong place, or at the wrong time, or under conditions that favoured decay instead of preservation. Civilizations are even less likely to fossilise. They are localised, concentrated, temporary. A coral reef covers thousands of square kilometres and persists for millions of years. A city occupies a valley and lasts centuries. The reef becomes limestone. The city becomes dust. This is not speculation. We already see it happening. Consider ancient human settlements. Many of the oldest known cities, Uruk, Çatalhöyük, Mohenjo-Daro, survive only because they were rapidly buried. Floods, abandonment, sedimentation, preservation through catastrophe. Without burial, they would not exist today. Now project backward. What would survive from a civilization 50 million years old? No metals, no buildings, no roads, no machines. Even stone tools would likely be destroyed. The only things that might remain are chemical fingerprints, carbon isotope shifts, unusual metal concentrations, extinction boundaries, synthetic compounds, if they could survive. And here is where the silence becomes ambiguous, because Earth's past already contains these fingerprints. There are carbon isotope excursions, sharp ones, rapid ones, ones that resemble industrial emissions. There are mass extinctions, sudden, global, severe. There are strange sediment layers enriched in rare elements. Science explains these events through natural mechanisms, and rightly so. Volcanoes, methane hydrates, orbital cycles, asteroid impacts. But the form of the evidence is not unique. The same signals we expect from industry can also arise naturally. This is the blind spot. If something unprecedented occurred, something not anticipated by our models, we would almost certainly misclassify it, not out of negligence, out of method. Science is conservative by design. Extraordinary explanations are avoided unless extraordinary evidence demands them. This is what makes science reliable, but it also means it is slow to recognise the unexpected. Frank and Schmidt were careful to emphasise this. They did not argue for lost civilizations. They argued for humility. They argued that the geological record is not capable of answering certain questions definitively, and this has consequences beyond Earth, because we are now searching for life elsewhere. We scan exoplanet atmospheres for oxygen, methane, carbon dioxide. We search for techno-signatures, radio signals, industrial pollutants, artificial light. We assume we know what civilization looks like, but if Earth itself cannot reliably preserve the evidence of technological intelligence, what chance do distant planets have? What if civilizations rise and fall quietly? What if intelligence is common, but permanence is rare? This reframes the so-called Fermi paradox. Not, where is everyone, but why does no one last? Earth might not be an exception. It might be the rule. And now we return to ourselves. Our civilization feels immense, dominant, indestructible. We reshape landscapes, divert rivers, drill into the crust, launch machines beyond the atmosphere. But geological time does not care about scale. From Earth's perspective, we are already a thin layer, a blink. The buildings we obsess over will be gone in 1,000,000 years. The roads, the cities, the monuments, all erased. What remains will not tell our story the way we intend. Future observers will not find our art. They will not read our books. They will not hear our music. They will see a spike, carbon, extinction, radiation, plastic, and then silence. This is the same silence we see when we look backward. It is not empty, it is erased. And that is why the question of whether someone came before us cannot be answered easily. Because Earth does not preserve civilizations. It destroys them, slowly, thoroughly, indifferently. The unsettling possibility is not that we are missing evidence of a past civilization. It is that evidence itself is temporary. And if that is true, then the deep past may contain chapters that no one will ever read, not because they were never written, but because the planet itself turned the page. In the next segment, we will examine the events in Earth's history that look disturbingly familiar: carbon spikes, climate collapses, extinction boundaries, and ask a sharper question: not were they artificial, but could we tell if they were? There are moments in Earth's history where the numbers stop behaving. Graphs flatten for millions of years, then suddenly explode upward. Temperatures rise too fast. Carbon appears too quickly. Oceans change chemistry in what amounts to an instant, geologically speaking. These moments are not myths. They are measured in stone, and they are deeply unsettling. One of the most studied occurred roughly 56 million years ago, at the boundary between the Paleocene and the Eocene epochs. To a geologist, it is a thin band of clay. To climate scientists, it is a warning encoded in rock, the Paleocene-Eocene thermal maximum, or PETM. Before it, Earth was warm, but stable. After it, the planet was transformed. Over a period estimated between 5,000 and 20,000 years, an eye blink in geological time, global temperatures rose between 5 and 8 degrees Celsius. Polar regions became subtropical. The deep oceans lost oxygen. Entire groups of marine organisms vanished. And most importantly, carbon flooded the system. Not slowly, not gradually, abruptly. The carbon carried a distinct isotopic signature. It was depleted in carbon-13, indicating it came from organic sources rather than volcanic rock. This matters because it narrows the list of possible causes. Scientists have proposed several explanations, all natural. The most widely accepted involves methane hydrates, vast reservoirs of methane trapped beneath the seafloor. Methane is extremely rich in carbon-12. If destabilised, it would flood the atmosphere with greenhouse gas and drive rapid warming. But methane hydrates do not destabilise spontaneously. Something had to trigger them. One hypothesis points to massive volcanism associated with the opening of the North Atlantic. Lava flows covered enormous areas. Carbon dioxide poured into the atmosphere. Oceans warmed just enough to release methane hydrates, amplifying the effect. Another hypothesis involves subtle changes in Earth's orbit, Milankovitch cycles, nudging the climate across a threshold. Both explanations are plausible. Both fit the data reasonably well. And yet, when modern scientists compare the PETM to our current trajectory, something uncomfortable emerges. The rate of carbon release during the PETM appears comparable, possibly even slower, than what humanity is doing now. We are injecting carbon into the atmosphere at a pace rivaling one of the most extreme natural climate events in Earth's history. This alone should make us uneasy. But the Silurian Hypothesis pushes further, not to claim the PETM was artificial, but to ask a harder question. If it were artificial, would we know? Because the PETM looks exactly like what an industrial civilization might leave behind. A rapid carbon spike, global warming, ocean acidification, mass extinction. If a technologically advanced species had existed 56 million years ago, burned carbon-based fuels, destabilised ecosystems and collapsed, the geological record would look almost exactly like this. Not identical, but close enough to be indistinguishable without very specific evidence. And that evidence, synthetic compounds, radioactive isotopes, manufactured materials, would not survive 56 million years. Plutonium-239, one of the most durable nuclear signatures, has a half-life of 24,000 years. After 56 million years, it would be completely gone, not traceable, not inferable. Plastics would break down into simpler hydrocarbons. Concrete would dissolve. Metals would oxidize and disperse. What remains would be chemistry, and chemistry is ambiguous. This does not mean the PETM was artificial. There is no evidence it was. Natural explanations are not only sufficient, they are compelling. But the point is this: the geological record alone cannot rule out artificial causes once enough time has passed. That realization changes how we interpret silence. The PETM is not unique. Earth's history contains multiple hypothermal events, periods of rapid warming associated with carbon release, the early Eocene climatic optimum, the Torsian oceanic anoxic event, several lesser-known spikes scattered across deep time. Each has natural explanations. Each resembles industrial impact. Each blurs the boundary between geology and technology. And this leads to a deeper discomfort. We like to believe that if something extraordinary happened in the past, it would leave extraordinary evidence. But Earth does not preserve extraordinary events differently than ordinary ones. It preserves outcomes, not intentions. A volcanic eruption and an industrial civilization both inject carbon. An asteroid impact and ecological collapse both cause extinction. A nuclear detonation and a natural reactor both alter isotopes. From the perspective of deep time, cause is harder to infer than effect. This is not an argument for lost civilizations. It is an argument against certainty. Frank and Schmidt emphasized this repeatedly. Their paper was cautious, restrained, almost defensive. They were acutely aware of how easily their work could be misused. They did not claim evidence of prior intelligence. They claimed limits on detection. And those limits matter because we are now interpreting signals beyond Earth. We are searching exoplanet atmospheres for oxygen, methane, carbon dioxide, nitrogen oxides, gases that on Earth can indicate life or industry. But the PETM demonstrates that abiotic processes can mimic biosignatures. A planet undergoing massive volcanism could show elevated CO2. A world with active geology could produce methane. Even oxygen can accumulate through non-biological means under certain conditions. If Earth can fake its own industrial signatures through natural processes, then so can other planets, which means silence elsewhere may not mean absence, and detection may not mean intelligence. The universe may be full of planets that briefly host complexity, spike, collapse, and erase themselves. Civilizations may flare like matches in geological darkness, bright, brief, undetectable after enough time passes. Now consider this from another angle. What if intelligence arose before the Carboniferous period, before coal existed? Coal deposits formed between roughly 360 and 300 million years ago, when vast forests covered the planet, and fungi had not yet evolved to decompose lignin efficiently. Trees fell and did not rot, they accumulated and were buried. If a civilization existed before this window, fossil fuels would not exist for them to burn. Their industrial path would look nothing like ours. No coal, no oil, no gas. Perhaps geothermal energy, perhaps solar concentration, perhaps technologies we cannot imagine. Such a civilization could have reshaped its environment without leaving the same signatures we expect. And again, this is not evidence that such a civilization existed. It is evidence that our search criteria are narrow. We look for ourselves. And when we do not find ourselves, we assume no one was there. The PETM is a reminder that Earth has experienced rapid global transformations without leaving a clear signature of cause. It tells us that the planet can change violently and quickly, and then move on. Life adapts, new species arise, memory fades, and, after a few million years, even catastrophe looks natural. This has implications for our future, because one day we will become a thin layer too. Future geologists, human or otherwise, will examine our era. They will see the carbon spike, the extinction, the radiation, the plastics. They will debate causes. Some will argue for natural feedbacks. Some will point to solar variation. Some may propose intelligent agency. And unless something unmistakable survives, unless we leave something truly durable beyond Earth, our story will blur into the background noise of geology. We will become another PEM, another anomaly, another debate. And this leads to a final, unsettling thought. The Earth's most dramatic warnings may not come from prophecy or myth, but from its own past. Because the planet has already shown us what happens when carbon floods the system. It has already shown us how quickly ecosystems collapse. It has already shown us how long recovery takes. And it has already shown us that after enough time, no one remembers why it happened. In the next segment, we move away from deep chemistry and into human memory, to myths, flood legends, lost ages and ask whether they are fantasies or distorted reflections of real catastrophes humanity survived and barely remembered. There is a strange asymmetry in human history. Stone forgets, but stories remember, not accurately, not precisely, but persistently. Across cultures separated by oceans, languages, and tens of thousands of years, the same themes recur with unnerving consistency. A world before the world, a great destruction, fire from the sky or water from the deep. Survivors who rebuild, knowledge that is lost. This is not fringe speculation. This is a documented pattern in comparative mythology and anthropology, and it raises an uncomfortable question. If the geological record erases detail and archaeology captures only fragments, could human memory itself, distorted, symbolic, incomplete, be carrying echoes of events far older than we usually allow? Not evidence, not proof, but signals. Let us be very clear before we proceed. Myths are not historical records. They cannot be used as evidence of advanced ancient civilizations. They do not preserve technical details. They exaggerate, compress, and transform reality. But dismissing them entirely would also be a mistake, because myths are not random. They cluster around real human experiences, floods, droughts, earthquakes, volcanic eruptions, famines, migrations. And in some cases, we have been able to correlate mythological accounts with real geological events. One of the clearest examples comes from Australia. Aboriginal oral traditions describe coastlines, islands, and land bridges that disappeared beneath rising seas. For decades, these stories were treated as symbolic or fictional. Then geologists mapped ancient shorelines. The stories matched landscapes that were submerged over 7,000 years ago, not metaphorically. Geographically, these oral traditions preserve real environmental changes across hundreds of generations without writing. This alone should force us to reconsider how durable memory can be under the right conditions. Now consider flood myths. They are everywhere. Mesopotamia, the Epic of Gilgamesh, the biblical story of Noah, Greek myths of Deucalion, Hindu accounts of Manu, Chinese legends of Gunyu, Mesoamerican deluge narratives, Polynesian stories of drowned lands, Native American accounts of waters consuming the world. The similarities are striking: a warning, a vessel or refuge, a cleansing catastrophe, a rebirth. This does not require a global flood to explain. At the end of the last ice age, roughly 12,000 years ago, sea levels rose by more than 120 metres worldwide. Vast coastal plains were flooded. Entire human populations were displaced. Some regions experienced rapid inundation, not slow, gentle change. Glacial lakes burst. Ice dams collapsed. Meltwater pulses raised. Sea levels metres within centuries, sometimes faster. For people living on those coastlines, it would have felt like the world ending. Now imagine this happening repeatedly over thousands of years. Stories would accumulate, merge, condense. Different floods become one flood. Different catastrophes become a single memory. Myth is not history, but it is not hallucination either. It is compressed experience. And compression destroys detail while preserving emotion, fear, loss, survival, warning. This matters when we talk about forgotten civilizations, not because myths prove they existed, but because myths prove something else. Humanity has experienced repeated, large-scale disruptions, events severe enough to fracture continuity, events capable of erasing knowledge. Now layer this over what we already know. Homo sapiens has existed for approximately 300,000 years. Written history covers about 5,000 years. Everything before that relies on archaeology and memory. The archaeological record becomes increasingly sparse as we move backward. Stone tools endure. Wood decays. Textiles vanish. structures collapse. Social complexity leaves fewer traces than we assume. Most early human societies were not cities. They were networks, seasonal gatherings, shared ritual sites, and if something disrupts those networks, climate collapse, sudden cooling, famine, knowledge transmission breaks. You do not need a planet-destroying event to erase a civilization. You only need to break continuity. This is where the younger Dryas enters the conversation. Approximately 12,800 years ago, Earth experienced a sudden return to glacial conditions. Temperatures in the northern hemisphere dropped sharply, possibly within decades, maybe even years. The cause is still debated. The dominant explanation involves disruption of Atlantic circulation due to massive freshwater input from melting ice sheets. Another hypothesis proposes a cosmic impact, possibly a fragmented comet triggering airbursts and wildfires. This impact hypothesis is controversial and not accepted as consensus. But what matters for our discussion is not the cause, it is the effect. Rapid cooling, ecological disruption, megafaunal extinctions, cultural collapse. Archaeologically, we see a break. In North America, the Clovis culture disappears. In the Near East, early experiments with sedentism falter. Populations fragment. Knowledge that depends on stable transmission, navigation, architecture, complex ritual, can vanish within generations, not because it was false, because there was no one left to remember. This is how civilizations are lost, not with ruins, but with silence. Now consider Göbekli Tepe, over 11,000 years old, monumental stone architecture built by hunter-gatherers. No agriculture, no writing, no metal, and yet organisation, symbolism, labour coordination on a massive scale. Göbekli Tepe should not exist according to older models of human development, and yet it does. And more, importantly, it was deliberately buried. The builders filled it in. They sealed it. Why? We do not know. But the result is undeniable. A complex ritual centre, forgotten for 9 millennia. If that can happen in 11,000 years, what could happen in 50,000 or 100,000 or 300,000? Now add geology. Ice sheets advance and retreat. Rivers change course. Sediment accumulates. Continents move. The Sahara was once green. Doggerland once connected Britain to Europe. Coastal settlements are now underwater. Human memory fades. Stone erodes. Earth recycles. The result is not mystery, it is absence. And absence invites speculation. But speculation must remain disciplined. There is no evidence of a technologically advanced global civilization predating ours. There are no artifacts, no manufactured alloys, no tools, no synthetic compounds older than modern humans. But there is evidence of repeated global disruptions, lost landscapes, forgotten social complexity, cultural resets, geological events that resemble industrial signatures. This combination is unsettling, not because it proves anything extraordinary, but because it undermines certainty. We like clean narratives. Hunter-gatherers, agriculture, civilization, industry, us. Reality is messier. History loops, advances stall, knowledge fragments, and every time continuity breaks, the slate partially wipes. The Silurian Hypothesis does not claim hidden empires, it claims fragility. The fragility of evidence, the fragility of memory, the fragility of civilization itself. It suggests that if intelligence arose before us, even briefly, even locally, even imperfectly, it could vanish without a trace we recognize, not because it never existed, but because Earth is very good at forgetting. And humans are very good at telling stories about what they have lost, without knowing what it was. In the next segment, we will turn away from myth and memory and look directly at the planetary eraser itself, plate tectonics, erosion, subduction, metamorphism. the machinery that guarantees that nothing built on Earth is permanent, and why, if anything came before us, Earth itself may have already destroyed the proof. Imagine trying to write a diary on water. Every sentence dissolves as soon as the ink touches the surface. That is what building history on Earth is like. We tend to think of the planet as a stable stage where life plays out its story. Mountains feel eternal. Continents feel permanent. Stone feels immutable. But this is an illusion created by short lifespans. Earth is not a library. It is a furnace with memory loss. To understand why evidence of ancient civilizations, if they ever existed, would almost certainly vanish, we need to understand how relentlessly this planet erases its past. Start with erosion. Rain does not seem powerful. Wind does not seem dangerous. Rivers do not look destructive. But given time, they dismantle everything. Mountains rise through tectonic collision, then are ground back into sand grain by grain. Entire mountain ranges vanish. The Appalachian Mountains were once as tall as the Himalayas. Today, they are worn stubs of their former height. Cities would not stand a chance. Concrete cracks in decades. Steel rusts in centuries. Stone collapses in millennia. Within 10,000 years, an eye blink in geological time, almost every surface structure humans have built would be gone without maintenance. Not ruined, gone. Now add burial. Sediment accumulates relentlessly. Floodplains deposit layers. Coastal regions drown and trap debris beneath mud. Volcanic ash blankets landscapes. Once buried, structures are crushed by pressure. Buildings collapse inward. Voids fill. Materials deform. Within enough depth, heat and pressure begin to rewrite the rock itself. This brings us to metamorphism. When rock is buried deep within Earth's crust, it changes phase. Limestone becomes marble. Sandstone becomes quartzite. Shale becomes slate or schist. Any structure inside that rock, fossils, tools, walls, loses its original form. Information is destroyed. Now consider plate tectonics. Earth's surface is divided into moving plates. They drift at a few centimetres per year, about the speed fingernails grow. That seems slow until you multiply it by millions of years. Where plates collide, one slides beneath the other. This is subduction. Anything on that plate, sediment, fossils, artifacts, is dragged down into the mantle and melted. The Pacific Ocean floor is almost entirely recycled every 200 million years. Nothing older survives. If a civilization built cities on the seafloor, on continental shelves, or near tectonic boundaries, the planet would literally swallow them. And it already has. Now consider where humans tend to build civilizations. Near water, coasts, river valleys, deltas. These are the most geologically unstable places on Earth. Sea levels rise and fall. Rivers shift. Sediment buries settlements. The most likely places for ancient civilizations to exist are also the most likely places for their remains to be destroyed. This is not speculation. We already see it happening. Doggerland, an entire inhabited landscape connecting Britain to Europe, now lies beneath the North Sea. Early settlements drowned. Evidence is scattered, fragmentary, incomplete. Multiply this process by tens of thousands of years, then by hundreds of thousands, then by millions. The Earth does not just hide evidence, it reprocesses it. And this has consequences for what science can detect. We assume that if something existed, it would leave obvious remains. But geology does not preserve obvious things. It preserves chemical signatures, isotopic ratios, mineral alignments, not stories, not intentions, not purpose. A city becomes rubble. Rubble becomes sediment. Sediment becomes stone. Stone forgets why it formed. This is why fossilization itself is so rare. Only a tiny fraction, perhaps less than 1% of all organisms that ever lived left fossils. And fossils are biased. Hard parts preserve better than soft. Marine organisms preserve better than terrestrial. Widespread species preserve better than localized ones. Civilizations are localized. They occupy small fractions of the planet. Even our modern cities cover less than 3% of Earth's surface. Most of that will vanish. Now imagine an intelligent species that existed for 10,000 years. That is a long time for us. It is nothing for Earth. Even if they built cities, roads, monuments, without constant maintenance, erosion would dismantle them. If they used materials like wood, fibre or simple stone, the chance of preservation drops further. If they lived during a time of climatic instability, ice ages, warming events, the destruction accelerates. Now consider time compression. The deeper you go into Earth's past, the thinner sediment layers become. Events that lasted centuries compress into millimetres. 1,000-year civilization could become a barely detectable line. And unless someone knows exactly where to look, it would be missed or misinterpreted, which brings us back to the Silurian Hypothesis. Frank and Schmidt were not suggesting ancient cities or lost technologies. They were pointing out a detection problem. They asked, what would survive? And the answer was unsettling. Almost nothing we would recognise. Radioactive isotopes decay. Synthetic materials break down. Artefacts vanish. What remains are planetary scale effects. Carbon spikes, extinction patterns, isotopic anomalies. But Earth produces those naturally too. Volcanoes inject carbon. Asteroids cause extinctions. Methane hydrates destabilise. Nature imitates industry. So even if an industrial civilization existed millions of years ago, its geological footprint might be indistinguishable from natural catastrophe. And science, correctly, defaults to natural explanations. This is not a flaw. It is how science avoids delusion. But it does mean something important. The absence of evidence is not evidence of impossibility. It is evidence of Earth's efficiency as a shredder of history. This does not mean civilizations existed before us. It means certainty is unjustified. Earth's past is not empty. It is overwritten. And the deeper we go, the more overwritten it becomes. In the next segment, we will examine the few things that can survive deep time, the faint fingerprints that persist when structures vanish, chemical anomalies, isotope ratios, planetary scars, the kind of evidence that does not look like ruins but like whispers, and why those whispers already exist in Earth's geological record. Imagine a civilization erased so completely that not even its name survives. No ruins rising from the sand, no monuments waiting to be rediscovered, no broken machines half buried in stone, only chemistry, only numbers, only subtle distortions in the planet's memory that look, at first glance, like nothing at all. This is where the question becomes truly uncomfortable. Because when we ask what can survive deep time, we are forced to abandon the image of lost cities and instead look at something far more abstract. The scars left on Earth's systems themselves. Civilizations vanish, but planetary disturbances linger. If an advanced society ever altered Earth on a global scale, burning energy, reshaping ecosystems, changing atmospheric composition, it would not leave behind buildings. It would leave behind signatures. And the unsettling truth is this: Earth's geological record already contains signatures that look disturbingly familiar. The most obvious is carbon. Carbon is life's fingerprint. It cycles through the atmosphere, oceans, biosphere, and rock. And when that cycle is violently disrupted, the disturbance leaves a trail. Carbon comes in different isotopes, primarily carbon-12 and carbon-13. Living organisms preferentially use carbon-12. So when large amounts of organic carbon are released, whether from fossil fuels, biomass burning, or methane, the ratio of these isotopes shifts. This shift is measurable, and it persists. Today, scientists can pinpoint the beginning of the Industrial Revolution in ice cores and sediment layers by this exact isotopic signature. The planet remembers what we burned. Now look backward. 56 million years ago, during the Paleocene-Eocene thermal maximum, the Earth experienced a sudden, massive carbon injection. Temperatures spiked globally. Oceans acidified. Species went extinct. The isotopic signature shows a rapid release of carbon depleted in carbon-13. Sound familiar? It should. It mirrors what we are doing now. Of course, the leading explanation is natural. Volcanism, methane hydrate destabilization, tectonic shifts. And those explanations are strong. But the disturbing implication of the Silurian Hypothesis is not that these events were artificial. It is that if they were, we might not be able to tell. Because industrial activity and certain natural catastrophes leave similar fingerprints. Fast carbon release, global warming, ocean chemistry changes, ecological collapse. The Earth does not label its disasters, it just records them. Now consider extinction patterns. Mass extinctions punctuate Earth's history. 5 major ones, dozens of smaller ones. Each appears in the fossil record as an abrupt disappearance of species. We attribute them to asteroids, volcanism, climate shifts. And again, those explanations are overwhelmingly likely. But extinction caused by technological collapse would look identical. A dominant species disrupts ecosystems. Food webs unravel. Specialists vanish. Generalists survive. From the rock's perspective, extinction is extinction. Intent does not matter. Now consider synthetic compounds. Plastics feel permanent to us. They are everywhere. But over millions of years, polymers break down into simpler molecules. They oxidize, fragment, integrate into sediment. Eventually, they resemble naturally occurring hydrocarbons. What makes plastics distinctive today becomes ambiguous deep in time. Metals behave similarly. Aluminum, once nearly absent in pure form, now blankets the planet. But given enough time, aluminum oxidizes, disperses, and reintegrates into minerals. The signal fades. Radioactive isotopes are more durable, but even they decay. Plutonium-239 lasts 24,000 years. After 1 million years, it is effectively gone. After 10 million, entirely erased. Which means that a civilization older than that leaves no radioactive fingerprint at all. Only indirect traces remain. The final, and perhaps most haunting category of evidence, is biological anomaly. Civilizations do not only alter chemistry, they alter life. Domestication changes species rapidly. Selective pressures intensify. Evolution accelerates unnaturally. If a technological species reshaped ecosystems, we might expect to see odd bursts of evolutionary change, species appearing suddenly, radiating rapidly, then collapsing. And we do see this again and again. The fossil record is full of strange discontinuities, sudden appearances, sudden disappearances, periods where complexity spikes, then vanishes. Science explains these patterns through adaptive radiation, environmental stress, and chance. And again, those explanations are likely correct. But the deeper lesson remains. The evidence we would expect from a vanished civilization looks exactly like the evidence of a stressed planet, which leads to a sobering realization. We are not just difficult to detect in deep time, we are indistinguishable from catastrophe. If another intelligent species studied Earth 50 million years from now, they would not see our cities, they would not see our art, they would not see our languages, they would see a sharp carbon excursion, a mass extinction, anomalous sediments, chemical disturbances, and they would likely conclude something bad happened here, not someone lived here. This is why the Silurian Hypothesis matters, not because it proves ancient civilizations existed, but because it reveals how fragile recognition is. It shows us that intelligence can rise, burn bright, and vanish without leaving a clear signature of intent. And that realization should make us uncomfortable, because it reframes our own story. We are not building a legacy, we are carving a scar. Before we go further, pause for a moment. Think about where you're listening from right now, what time it is. What part of the world holds you as these words unfold? If this exploration resonates with you, if these questions keep you awake rather than frightening you, consider staying with this journey. A like, a comment, or a subscription is not just support, it is a signal that curiosity still matters. Now let us continue, because the most unsettling implication has not yet been addressed. If Earth can erase civilizations so thoroughly, and if the evidence of collapse looks indistinguishable from natural disaster, then the greatest danger may not be extinction. It may be forgetting that it happened at all. In the next segment, we will step away from chemistry and stone and turn towards something more fragile and more persistent. Human memory, myths, legends, stories that survive where evidence does not, and why, across cultures and continents, humanity keeps remembering the same impossible things across the globe. In cultures separated by oceans, mountains, and entire continents, there is a curious pattern in ancient stories, one that modern scientists and anthropologists cannot fully dismiss as coincidence. These are not isolated folk tales confined to one people in one place. They are echoes, remarkably consistent echoes, of events so profound that they did something unusual. They became shared across humanity, even where no known contact between cultures ever existed. These narratives do not describe mundane human squabbles or local phenomena. They describe origins, great catastrophes, times before memory, episodes so universal that if they were invented independently, it would require an astonishing coincidence. For example, the idea of a great flood appears in Mesopotamian texts, including the Epic of Gilgamesh, thousands of years old. It appears in the Old Testament, in the story of Noah. It appears in the Mahabharata in India. It appears in First Nation stories in North America. And it appears in cultures in Oceania, Africa, and South America. These traditions all feature strikingly similar elements. A world that is destroyed by overwhelming water, a chosen few who survive, a new beginning emerging from the aftermath. The question is not whether people talk about floods. We know floods were real and common in antiquity. The question is why this specific narrative structure appears everywhere humans have lived, and why it is so persistent. Some scholars argue this is merely archetype, a shared psychological resonance, that humans tend to construct similar myths independently. There is psychological truth in that. Humans do tend to imagine catastrophic beginnings, but that explanation fails to account for the consistency of many mythic details that align uncannily with real geological and climatic events. For example, many flood traditions are geographically specific. Indigenous Australian accounts describe rising seas that match known post-glacial inundation events. Native American tribal lore reflects remembered shoreline changes along now submerged coasts. African and Middle Eastern legends reference rivers overflowing and carving new landscapes in ways that correspond with archaeological evidence of changing river courses. These are not generic flood stories. They are consistent with real events, not as literal history, not as archaeology, but as compressed memory encoded in narrative form. This is where myth intersects with geology, and it is far more Interesting and more unsettling than simply dismissing myths as fiction. Because if certain myths endure across cultures that developed independently, it suggests one of two things. Either these cultures inherited similar cognitive structures that produced the same stories independently, or they encoded memories of real, landscape-altering events into story form. There is also the strange case of lost lands in mythological memory. Stories of lands that existed before the sea covered them, legends of continents that disappeared beneath the waves, of islands that sank, of places that were once inhabited by ancient remarkable peoples and are no longer visible on any map. Consider Atlantis, described by Plato as an advanced landmass that vanished into the sea. Kumari Kandam, in Tamil literature, a lost land to the south called home to ancient civilizations. Lyonesse, from Cornish legend, a land west of Cornwall, said to have been swallowed by the sea. Lemuria, proposed in the 19th century as a land in the Indian Ocean to explain fossil distribution, and later absorbed into esoteric traditions. Modern geology does not support the existence of sunken continents in the places these myths describe. Tectonics and seafloor spreading make such land masses nearly impossible, but that does not explain why multiple cultures speak of land that once existed, where now there is only sea, unless those traditions reflect human memories of rising seas. Real inundation events experienced as catastrophic by the people who lived through them. And when you place this persistent mythic pattern alongside Earth's geological history, rapid climate changes, sea level rise at the end of the last ice age, evidence of catastrophic flooding in coastal regions, you begin to see why myths are treated by serious anthropologists not as childish dreams, but as compressed cultural memories, not evidence of ancient advanced civilizations, not proof of prehistoric aliens, not literal truth, but memory blurred by time, scaled up and mythologized so it becomes a universal story that survives where physical evidence cannot. This is the domain where mythology and geology intersect, at the boundary between what we can't find and what people remember. What makes the persistence of these stories even more intriguing is that they almost always involve a foundational rupture, a break between before and after in the human past, a world remembered as pristine, a world destroyed, and then a new world that begins again. Humans tend to encode deep personal memories, like loss, trauma, or transformation, into narrative. It's how the mind works. But the breadth of these flood narratives across every continent suggests something deeper, something shared, something lived. Perhaps not as literal history in every case, but as collective memory of events that altered environments suddenly, catastrophically, or dramatically, enough to disrupt human life on a large scale. And these events could have occurred multiple times in deep prehistory, thousands of years before writing, before cities, before structures that leave archaeological footprints. The myths do not point to proof of prior civilizations, but they demand explanation, not because they are true in the way a textbook is true, but because they are too widespread and too consistent to be dismissed without careful analysis. And this brings us back to the original question. If such events were remembered across cultures that had no contact with each other, what were they remembering? What kind of past could imprint itself so deeply on the human psyche? In the next segment, we leave myth behind for a moment to examine a real ancient site, one that upended archaeologists' ideas about the origins of civilization when it was uncovered just a few decades ago. And the age of that site forces us to rethink the timelines we take for granted. It is a place that sits at the edge of memory, where archaeology begins to fill the gaps that geology cannot. Before we go any further, pause for a moment and notice where you are right now. What time is it for you? Is this story unfolding in the quiet of night or somewhere between sleep and waking? If you're finding this journey meaningful, staying with it, subscribing, leaving a like, or simply listening all the way through, quietly supports the kind of long-form storytelling that allows these questions to be explored without shortcuts. Now let us continue. In southeastern Turkey, not far from the modern city of Şanlıurfa, there is a low rounded hill that for thousands of years appeared entirely unremarkable. Farmers ploughed its slopes. Shepherds rested their flocks nearby. No one suspected that beneath this hill lay one of the most important archaeological discoveries ever made. The site is called Göbekli Tepe, and its existence has permanently altered our understanding of early human history. When archaeologists finally began excavating it in the mid-1990s, they did not uncover simple dwellings or primitive tools. They uncovered monumental stone architecture, massive circular enclosures built from carefully carved limestone pillars, many standing over 5 meters tall and weighing as much as 40 to 50 tons. The pillars are not crude, they are precise. Each one is shaped into a distinct T-form, smoothed and balanced with extraordinary care. Many are carved with detailed reliefs of animals, foxes, boars, lions, snakes, vultures, rendered with confident artistic skill. There are no houses, no hearths, no permanent settlement. This was not a village, it was something else entirely. Radiocarbon dating revealed a fact that stunned the archaeological world. Göbekli Tepe was built around 9600 BCE, more than 11,000 years ago. This places it thousands of years before Stonehenge, the Egyptian pyramids, or any known city. And here is the detail that makes it truly disruptive. The people who built Göbekli Tepe were hunter-gatherers. They had no agriculture, no domesticated animals, no pottery, no metal tools. According to the long-accepted narrative of human development, such a society should not have been capable of organising labour on this scale. Yet Göbekli Tepe exists, and it forces a profound rethinking of how civilization begins. For decades, archaeologists taught a clear sequence. First came agriculture, then food surplus, then permanent settlements, then social hierarchy, then religion and monumental architecture. Göbekli Tepe reverses that order. Here, monumental architecture appears before farming. The evidence suggests that people gathered seasonally from across the region to build and use this site. The animal bones found there indicate large feasts, far beyond what a single small group could provide. This implies organisation, planning, coordination and shared belief, something powerful enough to bring hundreds of people together repeatedly, generation after generation, something symbolic, something ritual. Göbekli Tepe appears to have been a ceremonial centre, a place where meaning mattered more than survival. And this raises a question that archaeologists are still grappling with. What kind of worldview motivates hunter-gatherers to build massive stone monuments? One possibility is that religion itself may have driven the birth of civilization, rather than the other way around. Shared ritual creates shared identity. Shared identity creates cooperation. Cooperation allows large projects. And once people gather regularly in one place, agriculture becomes advantageous. If this interpretation is correct, then Göbekli Tepe represents not the dawn of civilization, but a threshold moment where humanity crossed from purely survival-based existence into something psychologically and socially new. But there is another detail that makes Göbekli Tepe even more haunting. After centuries of use, the site was deliberately buried. The builders filled in the enclosures with soil and rubble. They did not abandon it and let nature reclaim it. They sealed it, carefully, intentionally. Why? There is no consensus. Some suggest ritual closure. Others suggest a shift in belief systems. Still others wonder whether a catastrophic event forced the abandonment. What matters is this: a monumental site that required enormous effort to build was intentionally erased by the very people who created it, and then it was forgotten for over 9,000 years. This is the edge of memory, the point beyond which even the most extraordinary achievements can vanish completely from human awareness. No myths preserved Göbekli Tepe. No legends remembered it. No oral tradition carried its name. It was gone until modern archaeology stumbled upon it by chance. And Göbekli Tepe is not alone. Nearby sites like Karahan Tepe and other locations across southeastern Anatolia reveal similar structures. Together they point to a previously unknown cultural horizon, a society capable of symbolic thought, coordination, and monumental construction far earlier than expected. Not a lost advanced civilization, not a forgotten technological empire, but something equally important: proof that human complexity emerged earlier, faster, and in more fragile ways than we assumed. If something this significant could vanish so completely, what else might have existed that we have not yet found? And now we arrive at a difficult but necessary clarification. Göbekli Tepe does not prove that there were industrial civilizations before us. It does not support claims of prehistoric machines, global empires, or lost high technology. What it does prove is something more subtle and more important. It proves that our timelines are incomplete. It proves that absence of evidence is not evidence of absence, especially when preservation depends on luck, geology, and chance discovery. And it proves that human memory has limits. Without writing, without durable records, even the most astonishing cultural achievements can be erased in a few thousand years. Now consider this. Modern humans have existed for roughly 300,000 years. Göbekli Tepe is 11,000 years old. Less than 4% of that span. What happened in the other 96%? We have stone tools. We have scattered bones. We have cave art. But we have almost no insight into social structures, belief systems, or large-scale organisation for most of that time. Not because nothing happened, but because memory does not scale well into deep time. And archaeology can only recover what survives erosion, burial, and chance. Göbekli Tepe stands as a warning against certainty. It reminds us that the human past is not a straight line of progress, but a fragile sequence of experiments, some remembered, many forgotten. And if a site like this could remain hidden until the 1990s, then the silence before it may not indicate emptiness, it may indicate loss. In the next segment, we move from archaeology to catastrophe, to a moment near the end of the last ice age, when the Earth's climate shifted violently and suddenly, an event that disrupted ecosystems, altered human populations, and may have erased entire chapters of prehistory, an event known as the Younger Dryas. Now imagine the Earth holding its breath. For thousands of years, the last ice age was ending. Glaciers that had dominated continents were retreating. Sea levels were rising. Forests were spreading northward. Life was reorganizing itself into a warmer, more stable world. Human populations were expanding with it. They followed migrating animals. They experimented with new tools. They began settling longer in favourable regions. Everything suggested continuity. And then, abruptly, the process reversed. Around 12,900 years ago, the Northern Hemisphere experienced one of the most sudden and severe climate shifts in the last 100,000 years. Temperatures in the Greenland dropped by as much as 10 to 14 degrees Celsius, not over centuries, but within a few decades, possibly even a few years. the warming trend stopped. Cold returned, glaciers stabilised or advanced again, rainfall patterns shifted, ecosystems collapsed. Scientists call this event the Younger Dryas, named after a cold-loving flower whose pollen suddenly reappeared across Europe. What makes the Younger Dryas so unsettling is not that it happened. Climate shifts are part of Earth's history. It is how fast it happened. Ice core data from Greenland shows the transition as a near vertical line. One stable climate state ends, another begins. No gradual slope, no gentle transition, just rupture. For human populations living at the end of the Ice Age, this would have felt like the world breaking without warning. Food sources vanished, animals migrated or died, regions that had supported life for generations became inhospitable almost overnight, and entire cultural trajectories were disrupted. This matters because the Younger Dryas coincides with several other profound changes. Across North America, megafauna went extinct. Mammoths, mastodons, giant ground sloths, dire wolves, saber-toothed cats, dozens of large species disappeared within a narrow window of time. At nearly the same moment, the Clovis culture, one of the earliest well-documented human cultures in the Americas, vanished from the archaeological record. Stone tool styles changed, settlement patterns shifted, something interrupted continuity. For decades, scientists explained this through a combination of human hunting pressure and climate stress, and those factors almost certainly played roles, but they do not fully explain the abruptness or global synchronicity of the event. This led some researchers to propose a more controversial idea, that the Younger Dryas may have been triggered or amplified by a cosmic impact, not a single massive asteroid like the one that ended the dinosaurs, but a fragmented comet or multiple airbursts impacting or exploding over the ice sheets of North America. The hypothesis suggests that such an event would have ignited widespread wildfires, sent massive amounts of dust and soot into the atmosphere, darkened the skies, destabilized ice sheets, triggered rapid cooling. Proponents point to several lines of evidence. Layers of sediment dated to the Younger Dryas boundary contain microscopic spherules formed at extremely high temperatures, elevated platinum concentrations, rare in Earth's crust, but common in cosmic material, nanodiamonds that can form under intense pressure, charcoal layers suggesting massive fires. Critics argue that these signatures can be explained by terrestrial processes, volcanic activity, or misdated samples. And to be clear, the impact hypothesis remains debated. It is not settled science. But what matters for our story is not whether a comet caused the Younger Dryas. What matters is that the Younger Dryas was real, sudden, and catastrophic, and it occurred at exactly the moment when human societies were transitioning toward greater complexity. It represents a global reset, not total extinction, but profound disruption. If any early experiments in settled life, symbolic culture, or proto-civilization existed before this event, the Younger Dryas could have erased them almost completely, not through malice, not through intent, through environmental violence. This is how memory is broken, not by a single dramatic moment, but by the loss of continuity. Knowledge does not survive catastrophe if the people who hold it do not survive together. Survivors scatter, traditions fragment, stories simplify. What was once understanding becomes myth. What was once practice becomes symbol, and what was once lived experience becomes legend. This is where the flood stories matter again, not as proof of the lost empires, but as cultural trauma memory. Across the world, cultures remember a time when the sky changed, the waters rose, the land failed, the old world ended. These are not identical stories, but they share a structure, a before, a catastrophe, a survival, a rebuilding. The Younger Dryas provides a real geological candidate for such a memory. It does not require advanced technology. It does not require lost machines. It requires only humans living through sudden, terrifying change and trying to remember it. Now consider this. Göbekli Tepe was built after the Younger Dryas. Its earliest layers date to the period immediately following this cold reversal, which suggests something remarkable, that after one of the most disruptive climate events in human history, people did not retreat into chaos. They gathered, they built, they created meaning, they reorganized. In other words, catastrophe did not end complexity, it reshaped it. This pattern may have repeated many times across deep time, not civilizations rising and falling like empires, but human experiments in meaning, repeatedly disrupted by forces far larger than social organization. Each time fragments survive. Each time memory fades. Each time humanity rebuilds differently. And now, quietly, without spectacle, we return to the present. Because the Younger Dryas is not just a story about the past. It is a reminder that Earth is capable of rapid change, that stability is conditional, that human systems, no matter how advanced, exist within forces they do not control. In the next segment, we will confront the most uncomfortable question of all, not whether civilizations existed before us, but what the geological silence itself is telling us, what it means when the stone does not speak, and whether silence is the same thing as absence. There is a temptation, when confronting deep time, to treat silence as an answer. No ruins, no machines, no unmistakable artifacts buried beneath ancient rock. Therefore, nothing was there. Science often operates this way, and for good reason. Claims require evidence. Extraordinary claims require extraordinary evidence. And when we look honestly at the geological record, there is no direct, unambiguous proof of a technologically advanced civilization predating our own. No fossilized cities from 50 million years ago. No ancient reactors embedded in Precambrian rock. No industrial debris layered beneath dinosaur fossils. The stone appears quiet. But the Silurian Hypothesis, and everything we have explored so far, forces us to ask a subtler question. Not what the stone says, but what the stone is capable of saying at all. Because geology is not a recording device designed to preserve culture. It is a system that preserves process, pressure, temperature, chemistry, time. Civilizations do not leave neat signatures in those domains. They leave side effects, carbon anomalies, extinction boundaries, sediment disruptions, chemical residues, and even those are fragile. Imagine, again, our own civilization viewed from the perspective of deep time. 10 million years from now, every city erased, every monument gone, every database corrupted into nothing. What remains? A thin band in sediment cores where carbon ratios shift suddenly, a sharp decline in biodiversity, a brief pulse of radioactive isotopes, now mostly decayed, possibly a scattering of synthetic molecules altered beyond recognition. That is all. No explanation, no label, just anomalies. A future geologist might catalogue this as a rapid environmental perturbation. They might argue whether it was caused by volcanism, methane release, orbital variation, or unknown Earth system feedbacks. They would not assume intelligence. Why would they? They would do exactly what we do now. Look for natural causes. This is not arrogance. It is methodology. Science defaults to natural explanations because they are statistically more likely and testable. But that methodological strength also creates a blind spot, because if intelligence did leave a trace long ago, it would almost certainly be interpreted as natural unless the evidence was overwhelming. And overwhelming evidence does not survive geological time. This brings us to an uncomfortable but unavoidable conclusion. The geological record is not proof that we are the first civilization. It is proof that civilizations are hard to detect once time has done its work. The silence in the stone is real, but silence does not automatically mean emptiness. It may mean erasure, or compression, or transformation, or simply that we are listening with the wrong expectations. There is another factor that deepens this silence: location. Most human activity has always clustered near coastlines, rivers, deltas, fertile plains, and these are precisely the regions least likely to preserve evidence. Coastlines migrate, sea levels rise and fall, sediment accumulates rapidly, oceanic crust is subducted. If an early complex culture existed 50,000 years ago, or 100,000 years ago, or even 500,000 years ago, its most important sites would now be underwater, or gone entirely. And underwater archaeology is still in its infancy. We have mapped only a fraction of the seafloor at high resolution. Entire continental shelves, once dry land, remain unexplored, not because of conspiracy, but because it is technically difficult, expensive, and slow. What we do find underwater already challenges assumptions. Sunken landscapes, stone alignments, submerged settlements from the end of the last ice age. These are not advanced civilizations, but they prove a point. Human history is older and more submerged than we once believed. Now extend that idea further back, beyond writing, beyond agriculture, beyond memory. The silence grows. There is also the question of duration. Our industrial civilization is roughly 300 years old. If it ended tomorrow, its entire technological phase would occupy a geological instant. A civilization lasting 1,000 years, or even 10,000, would still be a blink. Compare that to 150 million years of dinosaurs, 400 million years of complex life, 4.5 billion years of planetary history. Even multiple cycles of rise and collapse could be lost within that scale, especially if those civilizations did not resemble ours, which is another assumption we rarely question. We imagine civilization as cities, machines, metal, industry, but intelligence does not require factories. Complex societies can exist without writing, without metallurgy, without fossil fuels. Göbekli Tepe already forced us to confront this. Hunter-gatherers organised massive construction projects without agriculture. Their complexity was social and symbolic, not industrial. What if earlier human cultures, or even earlier hominin species, developed forms of complexity that left few durable traces? What if intelligence expressed itself through ritual, landscape modification, biological knowledge, astronomy, oral systems? These leave almost nothing for geology to preserve. We tend to equate advanced with technological, but that is a modern bias. From the perspective of deep time, technology is fragile. Stone tools last, metal corrodes, concrete dissolves, digital information vanishes instantly. The more advanced a system becomes, the more dependent it is on maintenance, and the less likely it is to survive collapse, which leads to a strange inversion. The simpler a culture is materially, the more likely fragments of it are to survive, and the more complex it becomes, the faster it disappears. This may explain why the archaeological record shows a sudden appearance of civilization, not because nothing existed before, but because only certain kinds of things survive long enough to be seen. This does not prove that advanced civilizations existed before us. It proves that our confidence in absence is overstated. We are working with a broken archive, a planet that recycles itself, a memory system designed for chemistry, not culture. The silence in the stone tells us something very specific. Not that nothing happened, but that most things do not last, and now we must turn the question inward. Because whether or not civilizations came before us, one thing is certain. We are leaving a trace, a very clear one. In the next segment, we will examine what future observers, millions of years from now, are most likely to find. Not our achievements, not our art, but our impact. And what that means for how this story ends. Imagine the Earth long after us. Not 1,000 years from now, not 10,000, but 10 million. The continents have shifted slightly. Coastlines are unrecognisable. Mountain ranges have risen where plains once existed, and others have been ground down to nothing. There are no cities, no roads, no satellites orbiting overhead. There is no trace of language, culture, or memory, and yet something remains, not as ruins, not as monuments, but as signals embedded in stone. If an intelligent species were to arrive on Earth in that distant future, or if a future descendant of humanity were to study the planet with no knowledge of its own past, this is what they would find: a boundary, a thin, unmistakable line in sediment cores taken from oceans, lakes and ancient seabeds across the globe. Below the line, a world rich with biodiversity, stable isotope ratios, slow evolutionary change. Above the line, sudden collapse, simplification, a reshuffling of life. This boundary would stand out the same way the dinosaur extinction boundary stands out to us today. And like that boundary, it would demand explanation. The first clue would be carbon. Future geologists would notice an abrupt shift in carbon isotope ratios, especially the ratio of carbon-12 to carbon-13. This is not subtle. It is already measurable today. Fossil fuels are made from ancient plants that preferentially absorbed carbon-12. When burned, that carbon floods the atmosphere, oceans, and sediments with a distinctive isotopic signature. It is global, synchronous, geologically instantaneous. That signature will persist for millions of years, not because it is obvious, but because it is chemically baked into the planet. Future scientists would see it and ask the same question we ask about the Paleocene-Eocene thermal maximum. What caused this rapid carbon injection? They would propose natural explanations: volcanism, methane hydrate destabilization, orbital forcing, and just as with the PET, they would be mostly right, but they would miss something, because this carbon pulse would be paired with something else. A mass extinction. The sixth, not a total wipeout like the Permian, but severe, targeted, selective, large animals disappearing first, specialists collapsing, generalists expanding, rats, crows, insects, hardy weeds. This extinction would not look like an asteroid impact. There would be no global iridium spike, no single crater. Instead, it would look like prolonged ecological stress, habitat loss, rapid climate change, ocean acidification, overexploitation, which is exactly what it is. Future paleontologists would notice something else as well: a sudden global appearance of materials that should not exist naturally. Aluminum, in pure form, extremely rare in nature before humans learned to refine it. Concrete, in quantities rivaling the mass of living biomass during our time. Synthetic polymers, plastics broken down into strange repeating molecular patterns embedded in rock. These would be called technofossils, and they would be unlike anything seen before or since. But even then, interpretation would be difficult, because time erases context. A plastic polymer does not announce itself as a shopping bag. Aluminum does not come labelled as an aircraft wing. Concrete does not explain skyscrapers. All future observers would see are anomalies, patterns without stories, signals without language. Then there is the radioactive layer. Between 1945 and 1963, humanity detonated hundreds of nuclear weapons in the atmosphere. The fallout spread everywhere. plutonium-239, cesium-137, strontium-90. These isotopes created a global timestamp, a thin but unmistakable radioactive horizon that appears simultaneously on every continent. This layer will persist for tens of thousands of years. Its decay products will persist much longer. Future scientists will know this was not natural, because natural nuclear events, like the Oklo reactors, leave very different isotopic fingerprints. They will recognise this as something intentional, something technological, something abrupt, and then nothing. Above that layer, the signals fade, the radioactive markers decay, plastics degrade, cities erode, steel oxidizes, concrete crumbles. Within a few million years, the direct evidence of technology vanishes almost entirely. What remains is not a civilization, it is a scar, a brief but intense disturbance in Earth's systems. From the perspective of deep time, our entire industrial age will appear as a momentary fever. A species rose, altered the planet, collapsed or transformed, and was absorbed back into the background noise of geological history. Future observers might never know our name. They might never know our stories. They would not know about art, philosophy, love, or fear. They would not know that we asked questions about our past. They would only know that something happened, and they would debate its cause, just as we debate ancient anomalies today. This is where the Silurian Hypothesis turns the mirror toward us, because it reveals something deeply unsettling, not about ancient civilizations, but about us. If we were erased tomorrow, the future would struggle to understand us. They would argue about causes. They would build models. They would publish papers. Some would suggest natural explanations. Others might quietly wonder whether intelligence played a role, and most would dismiss that idea as unnecessary, because extraordinary claims require extraordinary evidence, and the extraordinary evidence would be gone. We would become a mystery, a boundary layer, a puzzle in the stone. And this realization reframes the entire question. The most important question is not, were there civilizations before us? The more important question is, what kind of trace are we choosing to leave? Because the earth does not preserve intention. It preserves consequence. It does not remember stories. It remembers chemistry. It does not honour achievements. It records disruption. From the planet's perspective, humanity is not a culture. It is a process, a force, comparable to volcanism, comparable to glaciation, comparable to impact events. This is not an insult. It is a scale problem. On geological timescales, even the greatest civilizations are brief perturbations. And yet, there is something unique about us, something no previous cycle, if any existed, could have done. We can see the pattern. We can look backward across deep time. We can study extinction layers, climate feedbacks, planetary limits. We can recognize that civilizations are fragile, that knowledge is easy to lose, that the earth forgets quickly, which means, for the first time, a civilization has the opportunity to act with awareness of the cycle, to choose not just survival, but continuity. In the final segment, we will confront the quietest and most important question of all, not whether we are alone, not whether we are first, but whether we will be remembered as another erased experiment, or as the civilization that learned how not to disappear. There is a strange comfort in thinking about the distant future. 10 million years from now, there will be no headlines, no arguments, no nations, only stone, ice, and slow-moving continents. And somewhere inside those layers, the faint echo of us. But the deeper truth is this: the future does not care whether we were first. It only reflects what we did. When scientists debate the possibility of ancient civilizations, what they are really wrestling with is not evidence of lost cities or forgotten machines. They are wrestling with impermanence, Because once you truly understand how easily everything vanishes, you begin to realise how fragile our sense of historical certainty really is. We believe we are standing at the peak of progress, but peaks are only visible in hindsight. From inside them, they feel like stability, and stability is the most dangerous illusion of all. Every civilization that collapses believes collapse happens to others. The Bronze Age cities believed their trade networks were eternal. The Maya believed their calendars would outlast time. The Romans believed their roads would never fade. Each of them left behind ruins that once felt as permanent as concrete feels to us now. What we call history is simply what survived, and survival is not proportional to greatness. It is proportional to chance. Stone survives better than wood. Burial preserves better than exposure. Silence lasts longer than memory. This is why the absence of evidence for ancient civilizations does not settle the question, but it also does not justify fantasy. The truth lives in the uncomfortable space between certainty and imagination, and that space demands discipline. What science tells us, clearly, honestly, is this. There is no verified evidence of industrial civilizations before ours, no machines in ancient rock, no artificial isotopes from deep time, no unmistakable technofossils older than our own era. And that matters, because skepticism protects us from inventing pasts that feel exciting, but are false. At the same time, science also tells us something quieter, something less often spoken, that Earth erases aggressively, that geological time is merciless to detail, that even a global civilization can be reduced to a thin chemical smear, and that means certainty has limits. The Silurian Hypothesis does not ask us to believe in lost empires. It asks us to acknowledge that our tools for seeing the past are imperfect, that we may never know everything that happened here, and that humility is not weakness. It is intellectual honesty. But now, after all of this, we must turn the question one final time, not backward, but forward, because the most important civilization in this discussion is not hypothetical, it is not buried, it is not forgotten, it is us right now. We are the first species in Earth's history capable of understanding planetary systems, the first to model climate feedbacks, the first to read extinction layers and recognize warning signs, the first to know with mathematical certainty that actions today ripple millions of years into the future, and that knowledge changes everything, because previous civilizations, if any existed, would not have known they were part of a cycle. They would not have recognized the early signals. They would not have seen the cliff until they were already falling. We do. That does not guarantee survival, but it removes ignorance as an excuse. The rocks do not judge, they record, and right now they are recording us. The carbon spike, the extinction curve, the synthetic layer, the radioactive horizon, these are not predictions, they are already written. What is not yet written is what comes after. Whether the layer that bears our signature is followed by recovery or by silence. Whether future observers will see humanity as a brief disruption or as a transition point. The moment a species became self-aware enough to change course. This is why the question of ancient civilizations matters. Not because we want Atlantis to be real, not because mystery is comforting, but because it reminds us how easily knowledge disappears, how quickly memory collapses, and how rare continuity truly is. If we vanish, the earth will heal. It always does. Forests will return, oceans will stabilize, new species will emerge. The planet does not need us. But meaning, memory, continuity, those only exist if someone carries them forward. So the final question is not hidden in stone. It is not buried in sediment. It is not waiting in myth. It is here, now. Will we become another forgotten layer, Or will we be the first civilization that understood the cycle and chose not to repeat it? That answer will not be found in the past. It will be written quietly, every day in the present. And whatever is written, the earth will remember, for a while. Then, like everything else, it will let go. And somewhere far in the future, someone may look down at a thin, strange layer in the rock and wonder who we were, and whether we understood what we were becoming. If you're still here with me, thank you. And before the night carries you away, I'd like to know, what do you think will remain of us? Sleep well. The past is vast. The future is listening.